All right, I think I'll just get started. So firstly, thanks for joining us. So we are part of Galileo, and I have my teammate with me, Roy, here. And if you've not heard of Galileo, we are a Gen AI evaluations and observability company. And we've been around for about 4.5 years, squarely in language modeling, and been dealing with LLMs and LLM-based systems for pretty much since day zero of our existence. Over the years, we've grown quite a bit. We're Series B at this point, and we've had the privilege of working with a lot of some of the largest banks in the US, some of the largest telcos in the world, and they're all using us to essentially ship reliable Gen AI applications and really build a system of robust evaluations and observability for kind of their Gen AI ecosystem. Because it's not about just one app or just a single thing that you build. It's more like, how do you set up yourself for scale? And a lot of it is about preventing flying blind, answering questions like, hey, if it did something wrong, can I root cause it, and can I fix it so that it doesn't make the same mistake? So really, it's a platform that allows you to bring in that level of diligence and responsibility in your workflows as you're building, right from day zero, as you start building, all the way to you have an application in production, and how do you guardrail it, how do you safeguard it to prevent bad outcomes. So this talk was originally titled, it was something else. It was Taming Rogue Agents with Evals-Driven Observability. And it was a bit of a mouthful. So I thought about what I really wanted to leave you guys with. And it was really about a new reliability playbook, kind of a playbook which takes the best practices from the previous era and bakes it into the new world of agents and orchestration systems and LLMs, really. Like, how do you build a robust system of evals in the new era? So with that, I want to start with kind of an ironic graph. And it basically states that as the couple of years have gone by since ChatGPT happened, the intelligence of LLMs has gone up. But if you talk to any leader in the enterprise, and I speak to leaders every other day, just the level of confidence in putting something out there is either stagnant and in most cases has come down. And it's a bit ironic given models can do a lot more than they could 2 years ago and at a fraction of the price. But there's a reason for this. And the reason is that we've kind of gone from basic elementary systems and workflows to a lot more complicated multi-agentic systems which are interacting with each other. So we figured out a formula to build more sophisticated things with LLMs that are not just question and answering systems, but they can actually do things. But the question still remains, how do you evaluate them? And how do you know whether they're doing the right thing? And can you quantify it, automate it, and do this at scale? In fact, even the RAG system that we all know, the simple architecture that you see at the top with the vector store and the prompt, that has evolved into something a lot more sophisticated. In fact, we work with customers who are very large companies across financial services and consumer goods and telco who are building internal RAG systems which have memory and context management. They have a citation platform which is often using data lookups to various systems, using tool calls and using APIs. So this is the new RAG of 2025. And that this is just to say that a lot of the newer systems we are building, especially with agents in the mix, are a lot more nuanced and have a lot more moving parts, which is why the confidence to release them out in the world without any harness and evaluations is that's the question in leaders' minds, that hey, I run a large company and yeah, I want to do something in Gen AI. I'm sure a lot of you guys also are strategizing your Gen AI strategy right now. But the question remains, yeah, what if something goes wrong? and it can harm the business, it can harm the brand, and the probability of that happening is a lot more despite all the advancements in the last couple of years. Before I kind of go into the meat of the presentation, I wanted to take a step back and kind of just align on what an agent is. So just grounding us on the same definition of agent. Agents, really simply put, are essentially a system that can plan and take actions based on data and instructions. If you simplify it down, that's essentially what they're doing. They can be constructed in simple or complex ways, but at the end of it, you're essentially supplying the right information to a set of functions or tools to take an action. There's different constituents of an agent, but primarily there's three big parts to an agent. First is kind of the reasoning or the brain of an agent, which really it's the difference between software 1.0 and 2.0 in that software now can think. So that's the reasoning of the brain of the agent. Then there's memory. You can build an entire system of memory management which submits the right context to the reasoning bit so that the next interaction has more data available from past interactions. And finally, there's the tools, which are these, you can think of tools as idempotent functions which do very deterministic things, but the quality of the execution can vary drastically if you submit the right or the wrong information. So these are the constituents of an agent. A lot can go wrong with agentic systems. I'll give you an example of one undesirable agentic behavior. And this is something that we've seen with some of our experience with Fortune 100 companies. An agentic bot asks, how can I help you? The user says, do you have corporate cards? And it asks you about good interest rates. The agent will gather that and ask it for more information. The user supplies the information, and it goes ahead and does something completely different. And this might be shocking here on a slide, but you'll be surprised to know how often this happens. And these are kind of the issues. These are the reliability problems of agents. There's three reasons why these kind of things happen. I put them as three obstacles to reliable agents. First is just the inherent unpredictability in these language models, right? That's kind of a restriction that you're dealing with. That can lead to tooling mistakes, memory errors, incorrect tool selection, but that's basically because of the inherent stochasticness of LLMs. The second impediment or obstacle is prompt sensitivity. So if you talk to anyone who's built a fairly sophisticated agent, they would tell you that a single word or a single phrase, one sentence can make night and day difference between the output, good and bad output of the agent. That's where the importance of good prompt engineering comes in, where you want to supply the very specific instructions, but it's almost an art on how to select the right set of instructions. And it depends on the context, it depends on the request. That's why prompt engineering kind of becomes an art when you're building a good agent. And the third is the whole garbage in, garbage out problem, right? If you're building, as an example, an agentic RAG system, the quality of your retrieval will basically affect everything, right? The kind of data you retrieved. I kind of call it the compounding effect of tiny errors, where a small token here and there in your prompt or a document, whether it's present in your retrieval or not, will make all the difference between actually executing the right thing and going totally rogue. So the question becomes, how do you tame these agents given you know these impediments? At Galileo, through a lot of our experience with many of these companies, not just financial companies or telcos, we've even worked with companies of massive scale like Airbnb and Reddit who use Galileo to safeguard their content systems. The question was, how do we tame rogue agents? We came up with the principles of what we call integrated observability. And this is a bit of a mouthful. There's a lot going on here, but I'm going to go step by step, which is the meat of this presentation on how do you take this 8-step playbook of integrated observability and bake it into your GenAI workflows. And together is what will get you a Gen AI system that you can trust. A lot of people come and ask me, oh, what is that magic metric that will solve all my problems? Or, how do you detect hallucinations? It's less about a single metric or some kind of magic pill that will solve everything for you. It's really a system of integrated observability that you need to build. And what we realized is that it is a continuous system. It never ends. That's because your application will always meet new data, and there'll be issues like drift or new clusters or new topics of data that your application may or may not perform well on. But this playbook will help you not only detect it beforehand or but also prevent it from happening. And in case it happens, it lets you root cause effectively and prevent it from happening in the future. So with that, I'll get into the 8-step playbook for agentic reliability. Step 1 is creating the right evals for your agents, or the right metrics for your agents. Now I look at the play 1, and it kind of reminds me of test-driven development, if you've heard of it in the traditional world, where you need to think about your failure cases first and kind of design your testing ecosystem around them, and then you start building. Similar to that, here, the first step is to really think about what you want to measure. And the question is, or the challenge is that what you want to measure differs from application to application. That's where what we do as a platform is we say there's 3 kind of general holy grails of measurement that you want to do for agentic quality. And that includes, you want to measure your tool's error rate, tool selection quality, and action advancement, whether your agent is actually moving towards the goal that you set out for. But agentic architectures are custom architectures. If you've built agents before, you know that they can be built in a million different ways. In fact, one of my favorite blogs that I often quote developers is a blog that was written by Anthropic over 6 months ago, Building Effective Agents. And I like that blog because, number one, it's very simple to understand, but also it touches upon this idea that there's about 12 to 15 design patterns around agents which should cover a vast majority of sort of actions that you want to take. But the broader meaning behind that article is really that it's like a jigsaw puzzle. Like building an agent is like a jigsaw puzzle, and you can construct it in a million different ways, and custom architectures need custom evals. So we've had many customers who've used the Galileo platform to create all kinds of metrics for their agents. And you want to apply different evals at different parts of your system. So that's what agentic sort of reliability or building agentic metrics is all about. You think of the kind of the three things high level that you want to measure, but then you kind of circumvent that, or rather you augment that with custom metrics that you want to think about before you even start building your application. Step 2 is, once you have the evals kind of built out and set in your mind, you want to set up your experimental infrastructure. And I'll give you an example of what this means. It's a 4-step process to fixing an issue that you detect in agents in production. Firstly, you spot it. Usually it's a data issue, so you want to isolate the segment of data that you find anomalous. Once you isolate the anomalous data, you want to do an experiment. Now, what the purpose of experiments usually is to kind of isolate the data that was misbehaving or that caused the agent to misbehave, and then you experiment with different prompts, different LLMs, or different sets of documents, which means if you have a vector store or some kind of database where you're fetching data from, you want to tweak the parameters to see whether you're fetching the right data or not. But setting up your infrastructure to be able to do that at speed kind of becomes important, because what your eventual aim is to, once you detect an issue, you want to quickly know what to change to not make that issue happen again. And it's kind of like, I found a dirty sock and I want to change the machinery around it to get to a clean sock, and I compare the clean and the dirty sock like here. And then I know what constitutes my clean sock, and then I quickly reconfigure my app. Play number 3 is kind of, I think, one of the most important plays. It's all about the prompts. And this is primarily because a lot of agentic engineering is prompt engineering, and a lot of like sophisticated developers will say that, man, like I've been tweaking strings for a living at this point. That's where I think an organized system around prompts becomes super critical. Just 2 days ago at the Databricks Summit, someone introduced me to the concept of prompt folding, which is essentially sort of dynamically adjusting or minimizing certain parts of the prompt or folding it to adjust to the context length issues, etc. So, being able to manage prompts dynamically, version control them because you're constantly editing them, tweaking them, giving you the lineage of the prompts, and essentially giving you a way to build, test, and compare prompts and doing experiments on them becomes very critical. So building that discipline in prompt engineering is one of the most critical plays in this agentic observability playbook. Number 4 is kind of something that's pretty brass tacks, which is any observability platform that you've used should offer you the ability to debug traces. But what we've realized is each request is a trace, and if you get the ability to look at what happened at each step of the trace, that's necessary but not sufficient, because there's 3 levels of debugging that you need to do. Firstly, at the trace level, then at the, you can call it a session level or an interaction level, which is kind of like a set of traces that is trying to accomplish a subtask, and then at the application level, which is the top level. So you want to set up analytics at all these 3 levels to be able to have that 360 view of the health of your application. Number 5 goes into the importance of kind of offline guardrailing, which is CI/CD. And how do you bake in agentic tests and agentic evals into CI/CD? And a lot of this is traditional software engineering discipline that we've all seen and worked on before. The only difference is now you're kind of testing and validating different components, right? You have prompts, you have parts of your agentic app which are LLM driven. So how do you mock those? You have machine learning. This is a machine learning system, right? So you have data sets. Sometimes you may have ground truth and may not have ground truth. So how do you bring all these eval assets into your CI/CD? I think that becomes super important. But the overall purpose of baking in these tests in CI/CD is the same, that your agentic app is kind of like any other app, except that it's a smarter app, and it goes through the same life cycle of being developed on localhost, put into your dev clusters, and all the way to Canary, and finally in prod. And you probably have some kind of an automated system that's set up for your traditional software. You need these components for your GenAI app as well, and you want to set up testing for that. And I'll get into a little bit more detail on how you set up agentic tests in one of the future plays. But before that, I want to talk about the most important thing. Once you productionize applications, now what? And this is one area where Galileo truly shines. I think we've done a lot of innovation on how to do evals at scale. Some of the models that we've built, which are instruction tuned and done few shot learning on some of these lighter weight eval models, our internal experiments have benchmarked them against a lot of the industry standard open source tooling as well as cloud provided solutions. We're able to give you evals at very high scale. If you use LLM as judges, they work great in offline environments. Once you start hitting a certain level of throughput, you're at the behest of the LLM provider, whether it's context limit issues or rate limits. And I don't think I need to explain that. So, but we have had the experience of seeing folks trying to productionize LLM as judge metrics, and it's a pain. So that's where if you have beyond a certain level of throughput, you need super accurate and fast evals that work at scale. And this is one area of research that we've put in a lot of resources on. And this is where we truly shine. We not only get you to production through our platform, but in production, we are able to give you these these very high scale SLM, small language model driven metrics. And to be more specific, we've done a lot of experiments with the different flavors of the newer llama models, kind of 2 to 8 billion parameter, and we've achieved significant success in being able to give you LLM as judge level accuracies, but at a fraction of the latency and cost. The seventh play, and we're almost there to the final one, which is number 8, but seventh one is super important. It ties to play number 6, play number 5, which was the CI/CD play. Here, the question becomes, how do you create test sets for agents? Like, how do you test agents, right? Agents are essentially functions. You test them kind of using what we call like agentic test sets. The question is, what is an agentic test set, right? If you look at traditional data sets, say you're doing a simple call to OpenAI, or you've fine-tuned a model, right? How do you test a model? You have a query, you have a ground truth, you have a model response, and then you measure some kind of a measurement between the ground truth and the response, and then you say that, yes, it's a pass or a fail. It's very similar with agents, except that the intermediate outputs of agentic systems are usually JSON serializable or some kind of an intermediate representation. So you want to test those, but you don't want to, in a test environment, you don't want to do real LLM calls. Maybe you want to mock them. That's where there's some specific constructs that we've baked in as part of the Galileo SDKs, which allow you to author these agentic test sets and put in these little sort of measurement classifiers, which you'd be used to in the traditional sort of testing world, whether for example, is null is a construct. There's a whole host of those which you can bake into tests. And then now this data set is usable in your CI/CD workflow. And we've had success taking a few of our customers' CI/CD workflows and baking these kind of agentic tests in them. The last play is all about metrics. And the principle of the final play is that there's no one metric which will work for you all the time. Even if you say that I know what my definition of hallucination is, you can author a metric, LLM as judge, or whatever you're using behind the scenes. The truth is that as you productionize your app, the definition of your metric will evolve, and you'll start yielding false positives. So how do you safeguard and guardrail against that? We created this concept of evaluation agents, which are essentially taking these metrics and these evals and auto-adapting them to your data. This is kind of the workflow where you have a baseline metric, it yields a false positive, and now you need to do something to improve it over time. What we've seen is that there's a feedback framework that you need to build, which is low-touch human feedback. And using that feedback, you make the metric not make that mistake later. And how do you achieve this is by, firstly, you want to centralize metric as an artifact in your platform. Like a metric is a reusable entity which is stored in a database, and others can use it, so that if user 1 detects an anomaly or a false positive, they submit an instruction to the metric telling it that, oh, this is the reason it was wrong. When it's used in the future by another user, the same metric shouldn't make the mistake. So all this machinery together is part of a metrics platform. But going deeper into the effect of different kinds of feedback, this is kind of a research area that we've delved deep into with our AI researchers. There are 3 types of critical feedback that we explored and its effect on the accuracy of a metric over time. There's a binary preference signal, which is basically a thumbs up, thumbs down kind of feedback, very low touch. There's the critique of explanation, or COE. What that is it's essentially a verbal feedback that is a critique of why a value was, or the explanation behind a value was wrong. In Galileo, we augment each of our metrics or evals with an explanation of why the metric is a certain way, and it uses a technique called chain pull, which is a paper we wrote. It's an augmentation to LLM as judge, but it enables each metric to have this deep explainability. But our feedback system explored the effect of critiquing that explanation. And the third kind of feedback is critiquing the value itself. Say you have a hallucination metric, 0 to 1. If it's 1, that means it's good. 0 means whatever, hallucinatory. If there's a false positive, if you critique the value itself, there's a different effect that it has on the metric over time. And here's some of the results I'll show you. Some very interesting results of feedback on different metrics. So we took a baseline metric, which is the black bar you see, and we gave it different forms of feedback over time. And we realized that actually short feedback over time is actually better than long feedback. If we can go deep into why, and we explored potential reasons where the loss in the middle phenomenon happens with LLMs, etc. But the short of it is that if you detect a false positive, you give multiple pieces of shorter feedback over time, you actually get a better, longer lasting metric. And secondly, high quality descriptions of your feedback as well as of your metric. If you author a custom metric, even if it's LLM as judge, always give it a very high quality description. Because over here you can see the performance. The black bar is a high quality metric using a phenomenon in Galileo called autogen, which is the ability for you to create a metric on the platform. So you create a high quality metric versus the same metric, which is, we took these two metrics, instruction adherence and PII, which are kind of, the first one is a hallucination metric, and the other is a, of course, private sensitive data metric. But we created two different versions of it, and you can see the baseline performance is astronomically different. But the more surprising thing is we took the low quality feedback and gave it the three kind of critiques, and look at how better it got over time. So that's the magic of low touch human feedback. And the reason this is the play 8 is because you need this kind of a human feedback mechanism for your evals baked in to your integrated observability playbook. So with those 8, I'll bring it back to the spinning wheel, or whatever you want to call it, like the infinite loop here. So the question still remains: how does integrated observability actually accelerate your workflows? And this is where I do want to show how Galileo as a platform is completely about this phenomenon. And this is how, during the development stage, we allow you to gather, ingest millions of signals from your GenAI app, analyze them, give you deep analytics, and then eventually fix them, root cause them efficiently. But also in production, this is where we've done a ton of innovation using our suite of SLMs, which we call the Luna suite of models. And they're able to achieve step function better accuracy. Not only that, but it's able to achieve end-to-end latencies, which are pretty unheard of. And that enables you to guardrail your chatbots or guardrail any kind of GenAI app which is in production, working at scale. And that's it. And with that, we'll do a little demo of the Galileo platform, and then we'll do questions after.
Make it a little bit bigger. Okay, so what I'm going to show you here is like a very, very high-level view of what the Galileo framework looks like a little bit when we're using it with an agentic application. So this is a small agentic application that I created that does some very basic things. It sort of simulates what it would be like to have sort of an agent, a banker agent with a simulated bank account, and basically it will allow you to move money between your accounts and go to do some buying on the stock market. So you could tell it, hey, go, I want to buy a certain amount of stocks in some sector, and it will go ahead and do that job for you. And that specifically is done by first looking at your accounts, calculating some risk profile, and then going to look based on your risk profile at the potential stocks that you want to buy, actually looking for those on the web, getting their ticker prices from Polygon, so like going out to some API, and then coming back with actual prices and executing that action against a sort of real bank account, right? Like, so I can actually remove funds from that account and move them into my stocks. So what you'll see here is like several sessions that this particular user has had with the system. First, they checked for the balance. Then they said they wanted to buy some tech stocks. The system kind of allocated this amount, even though they asked for to spend more. The system knew to allocate less, and actually did what it was supposed to, which was to buy some stocks. And then the user deposited more money into their account and went through this process again. And this time, the system actually failed to do everything that it was supposed to, right? So there was a step in there where there was a behavior that sort of looks like the agent completed. It does say that it failed with paying a specific bill, but it's unclear why this happened, right? So like I have this, again, and this happens a lot when you're developing agentic applications, when you're developing complex applications with a lot of LLM dependency. Things can go kind of haywire in that process, and it's very hard to track, again, what exactly went wrong and how did it go wrong, right? So I'll flip into Galileo and show you my trace for this particular session. So what you can see here is first I get like an overview of a set of traces. I'm going to flip back and forth between them so you could get a sense of what I'm talking about. And you'll see here that, you know, here I'm seeing each node of the activity that the agent took, right? So for example, here it's doing the initial tool selection, so it's getting some inputs, asking for balance, going through that and producing a particular name of a tool that it needs to call in order to produce that balance, and then it goes, you know, through the motion, gets the information that the user needs and outputs it. And in this case, I can tell that my action advancement is 100%, but for some reason my agent here thinks that it's not exactly doing what it's supposed to. So that already immediately gives me an idea that, hey, maybe something didn't work quite right. As I move along, I can see here that my first action worked as expected. So everything happened, like the entire transfer happened as expected. And then when I do it again, I can see that something went wrong. So like the system already identified that I had a goal, right? The user said something, in this case that they wanted to buy a certain amount of stocks, and that there was some failure that didn't satisfy what my user wanted, right? And this is an example of our agent-specific metrics, which again look at the entire action that an agent is performing with all of its constituent parts, and then can assess whether or not things worked as you intended or not. And as Atten mentioned, right, like these could be like out of the box, not exactly what I'm looking for, and I can on the fly kind of introduce my own logic and say, hey, this metric should look more like this or more like that, thus introducing my domain knowledge into the process itself. One last thing I want to show you here is my logstream insights. So our logstream insights is a relatively new feature, and what basically it does is it looks at the entire performance of my application overall, right? So beyond each trace, right, it looks at the overall performance of the application and it highlights things to me that it thinks might be problematic. So for example, here, it's telling me that I'm giving back inconsistent research. And it explains very deeply, right? Like, I won't make you read all of this, but it basically tells me, hey, you're giving for the same request that a user may ask. Sometimes you're giving 25 stock recommendations, and sometimes you're giving 3 stocks recommendations. So what's up with that, right? Is that what you intended to do or not? And some of these metrics, some of these insights that we're getting are things that you wouldn't have caught, right? Have you not tried many, many, many times to work with your own application? And even then, you wouldn't land on all of the more niche issues that might crop up, and you wouldn't even notice. In addition to that, right, they can also give me like some good indications, right? So like what, you know, like it understands that I have a multi-LLM architecture. It understands that I have a complex investment flow and sort of highlight again where it thinks that complexity arises. So that's another way for us as developers to kind of gain a more bird's level view understanding of what exactly is happening with our applications as we develop them. That's basically it.
I'll give one more example of an error that was detected in the logstream insights section with one of our customers, where an unauthorized transaction was executed, a financial transaction that was not asked. So that showed up as a red saying unauthorized transaction, and it was able to point to the specific trace where the agent made that mistake. So a tool like this, you can see that you spot the anomaly, we give you the shortcuts high level, and then you can dive super deep at the trace level to see specifically what happened.
And maybe one more thing to add here is that right here in this particular example, you're seeing just the agentic relevant metrics enabled. Of course, you can think of all of the things that we've seen in the last year or two kind of fold into this, or anything that's retrieval related, right? Like if you have a RAG tool that is just yet another tool in the chain, right? All of these retrieval spans are still interesting, and you could understand again, more about how your application operates just by looking at those, even beyond the agentic specific stuff. And of course, custom metrics go into that as well.
Totally. And what you saw is like probably 1 or 2% of Galileo. There's a lot of other stuff baked in, and you can use our SDKs and APIs to basically fetch all of these insights in your own app and guardrail them. And people have used Galileo in many innovative ways to safeguard their LLM systems. So just wanted to call out that this is just to show you 1 or 2 high-level workflows, but happy to take questions. So I have a QR code for you if you want to point your screen at it. It takes you to galileo.ai. Of course, you can just go there directly. But my email is right here. We've been doing this for a while, and we have a lot of battle scars of taking very serious GenAI practitioners into production. And we're also learning as we go, but certainly have the wisdom of, for whatever it's worth, this is a new area, but we've seen a few early applications, especially on the agentic front, being productionized. So we understand this area really well. If this is interesting, please email me, or we can chat right after as well. Always happy to chat with folks who are building cool GenAI stuff.